Okay, so Miss Headley gave you this sheet and you were supposed to kind of go through and write out some answers, kind of what you thought. There's really no right or wrong here. I just kind of wanted you to explore the picture, kind of see what was happening. So if you wrote in pencil, that's fine. If you have a pen, another color, or if you're going to erase, that's fine too. I just want to make sure that you get down the things that I say. So if that's not what you wrote, just make sure you've got something similar or write out notes in the side. So it says Ferris wheels are a popular attraction at fairs and amusement parks. The tallest one in the world was recently built in Dubai with an impressive height of 820 feet. What do you notice about the Ferris wheel shown in the picture, and what do you wonder? So if I was here with you, we'd kind of discuss like what you see. Maybe you saw that it was a circle, that it has 360 degrees. Maybe you saw that it has these letters, these 12 carts on it, that it's divided equally. Whatever things that you maybe saw. There's really nothing about that. That's just literally what did you notice about this and what do you wonder about? Okay, number 2 says, Abigail is sitting in cart A and George is sitting in cart G. If Abigail is 15 feet from the center of the wheel, how far away is she from George? So I'm hoping that maybe in your mind you thought, well, 15 feet is the radius. So from Abigail to George would be 30 feet because that would be a diameter. Now we're starting circles. We're going to kind of explore about different things. I feel like you've heard the word radius and diameter before. Radius being from the center to a point outside the circle, so halfway. Diameter being all the way across, so double the radius. Bo is sitting in cart B and Kara is sitting in cart K. Is the distance between them greater than or less than the distance between George and Abigail? So we have B here and we have K here. And if we drew like a straight line distance from them, is that, longer or shorter than from Abigail to George? And my hope is that you said less than. So we're going to talk in just a minute about that line segment that I just drew is called a chord. And so that chord is going to be smaller than the diameter because the diameter is going to be the greatest distance across a circle. So it would be less than because the longest distance is the diameter. What is the angle made between two adjacent spokes? So basically, what is this angle measure right here? If these are equally distanced apart around the circle, then hopefully you would have said 30 degrees. And how do I know it's 30 degrees? Well, there's 360 degrees divided by 12 because there's 12 buckets. And so 360 divided by 12 would be 30 degrees for each one of those. How many degrees does the Ferris wheel have to turn for Abigail to make it to the position where George is currently? So I'm asking if I'm at Abigail and I want to go to George, so I'm here and I want to travel around over here, how many degrees does it have to turn? Well, that's halfway across, so 180 degrees because that's a semicircle. 180 degrees semicircle. Then it says, the Ferris wheel turns clockwise. Lorelai is sitting in cart L and Darren is in cart D. How many degrees does the wheel have to turn for Lorelai to be in Darren's current position? How do you know? So now we're going to be trying to go from L, which is here, to D. Well, if we know that every time we kind of go one seat, that we're going 30 degrees, that's 4 times. So that should be 120 degrees because it was 4 of those little spokes. Anything that is smaller than a semicircle, we call a minor arc. And you're going to write that down later, so if you don't write it down right now, it's okay. A minor arc is anything smaller than a semicircle. How many degrees does the Ferris wheel have to turn for Darren to be in Lorelai's current position? So it's asking the opposite. So if I'm here and I want to get going all the way green, 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 all the way here. Well, the green plus the pink that I just did should equal 360, okay, because that would be a full rotation around. So this would be 240 degrees, and we call that a major arc. So 180 is a semicircle, less than 180 is minor, and greater than 180 is major. Okay, and then number 7 says, it takes 4 minutes for the wheel to make one complete rotation. Put a star at Beau's location after riding the wheel for 21 minutes. Well, if we ride for 21 minutes and it's 4 minutes is a full rotation, we should go around 5 times. But then after that 5 times, we've got 1 more minute. So you can kind of look at it however you want to. It's 12 spokes in 4 minutes, which would be 3 spokes in 1 minute. And so we're basically going, 5 rotations and then a fourth of a rotation. So we're going 3 spokes. So you would be from B and you would be at E. Okay? All right. I want you to kind of put the back of this over to the side. We're going to come back to the back of it in a minute. And Miss Headley's going to, if she hasn't already, she's going to give you this sheet that looks like this. And we're going to go through all the parts of a circle. So I'm going to do mine in some different colors. If you have different colors, that's fine. If you want to just do it all in pencil, that's fine as well. Okay, so most of us know a circle when we see one. We know that we think we know what a circle is. And so a circle is going to be this set of points, and there's an infinite number of points on a circle. Okay, it's like a line. So if there's an infinite number on a line, there's an infinite number on a circle, because remember, points don't have any thickness or width. And so the definition of a circle is the set of all points, a given distance, from a common point. The set of all points, that's what you would see around the circle. A given distance, that given distance would be your radius, from a common point, which would be your center, okay? That common point would be called your center. We name a circle by its center. So if I was going to name the circle here, I would name it circle J. You can just write J. Some people, if it's in a book, it'll have a little circle with a J. Some people write out the word circle. If you just put J, that's fine. But you always name a circle by its center. All right, next we're going to have a chord. A chord is a line segment in a circle with both endpoints on the circle. A line segment in a circle with both endpoints on the circle. So in this case, a chord would be like AC, but only the line segment part. Okay, only the line segment part is the chord. Anything outside of the circle, we're going to call something else. So like AC with a line segment over it. You could also say DG with a line segment over it. Your diameter is also a chord. Okay, it's just the longest chord. Okay, you've heard the word tangent before. We talked about that last chapter, but this is a little bit different, not the same type of tangent. So a tangent is a line that intersects a circle in exactly 1 point. A line that intersects a circle in exactly 1 point. So this guy right here, XM, that is your tangent. One thing I'd like for you to add, draw a radius here from J to X, because your tangent is always perpendicular to your radius. So make a little note out to the side, perpendicular to the radius. And then one other thing I want you to write is this X point right here where it touches the circle, we call that the point of tangency. The point of tangency. So the tangent line is going to touch the circle in exactly 1 point. And we call that the point of tangency. And it is perpendicular to the radius. Okay, I feel like we all know what a diameter is, but a diameter is a chord. So we just learned that word. The chord was the line segment, which intersects, kind of ran out of room. Let me move that down to the next line. A circle's center. A chord which intersects a circle's center. So your diameter is DG or GD here. And it is a line segment, so put line segment over it, not a line. And make yourself a note that this is the longest chord. Put a note in here that this is the longest chord. All right, next we have our radius. Radius is a line segment from the center to a point on the circle. So your radius would be like JF. There's more than one, but I'm just going to pick that one. And it's a line segment. So it goes from the center to a point on the circle. And it's half the diameter. Okay, now we're going to talk about secant. We heard that word last chapter also. Secant, again, different type of secant. So a secant is going to be a line, and I want you to underline line, which intersects a circle in exactly 2 points. A line which intersects a circle in exactly 2 points. So the chord is the line segment that stays inside of the circle, but the secant is going to be this whole line, and it's going to leave and go outside of the circle. So chord is going to stay inside like a diameter. The secant is going to be a line, so it's going to extend out. So we would do AC with a line over it rather than a line segment over it. Okay, I've got a few more things that we're not going to write the definitions out for, but we are going to label. So next, we just talked about this on the Ferris wheel page. Halfway around a circle is a semicircle. So I'm going to go this way. I'm going to go from G. I'm going to travel around, keep going all the way to D. That's going to be my semicircle. My semicircle is 180 degrees. And I'm going to name that with 3 letters, okay? So when I name it, I'm going to name it GXD, and I'm going to put a little arc over it. Arc, I'm saying, is ARC. It's the outside part of the circle. And so a semicircle is half of the arc, a half of the circle, a half arc, basically. And the reason I use 3 letters is because I need to get to know which direction I'm going. If I was going on the top half of the circle, I might name that GFD or GCD. But make sure you're using, 3 letters because I need to know which way I'm going here. Okay, we also need to talk about one that is smaller than a semicircle, okay? Smaller than a semicircle is called a minor arc. Minor being small. So minor is going to be less than 180 degrees. Minor arc, less than 180 degrees. And you name a minor arc with 2 letters. You name a minor arc, so we would name this FD with the little arc over it. 2 letters. That's going to tell me it's small. We're just going to that short space. Because otherwise, I could go the other way around, and that would be a major arc. So a major arc is going to be greater than 180. So I'm not going to actually label that since there's just a lot happening on this circle. I'm going to name it over here. So you can write it at the top. A major arc is going to be greater than 180 degrees. And so a major arc would be something like FXD, and it would start at F and go the other way around to D, greater than 180 degrees. All right, one more thing on this picture, and then we're going to turn it over onto the back. I want you to draw 2 things real quick for me. But the other thing on this picture I want you to label is an angle here. And that's an angle that's going to be have its vertex at the center, and its legs are those radii, and we call that a central angle. A central angle. All right, I'm going to leave that up for a second. Let you write down anything you might have missed. Okay, and on the back of that, if you'll draw 2 circles, I just want to draw, there's just so much going on. There's just 2 other things I want to label on here. I'm going to draw that central angle again. So a central angle is an angle whose vertex is at the center. And its legs are going to be those radii. So this is your central angle. And what you need to know is that angle and this arc are going to equal the same thing. So it's kind of like that Ferris wheel when we divided into 12 spots. Not only were those little angles 30 degrees, but every time we went to a different seat, that's 30 degrees. So if this angle in here is 60 degrees, this arc that's shaded right here would also be 60 degrees of the circle. And so make yourself a note that the angle and the arc are equal. Now, if you think about a clock, If I ask you to go from 12 o'clock to 3 o'clock, you're going 90 degrees. And if the hands of the clock were at the 12 and the 3, it would also make a 90-degree angle. So that should make sense about how that's working out. The other type of angle I want you to draw is what we call an inscribed angle. Inscribed angle. An inscribed angle is going to have the vertex on the circle. And its legs are going to be chords instead of radii. Okay? So inscribed angle. This is your angle. And instead of that being equal, your angle is going to equal half of your arc. So if this is 70 degrees of the circle on the outside, then this guy is going to be 35 degrees. So central angle is going to be equal to the arc. Inscribed angle is going to be half the arc. Okay, so that's a lot of info. So what I want you to do is I want you to go to the back of the Ferris wheel page, and you've got kind of a check your understanding. You don't need anything in this box. That's why we had that whole other page to label all that. And I want you to complete this. It says like name 2 chords, name a radius, name 2 major arcs, all of those things. Then the second part is asking you, are these minor arcs, major arcs, and what do they equal? And so I would like for you to complete this section, and then we will go over this and kind of talk back through circles when I return for the next class. And if there's something you missed in the notes and you want Ms. Headley to rewind, and go back and play something, she'll be happy to do that for you as well.